question this week about how to remember the difference between cations and anions. So I thought I would help you out a little bit by going to this particular website. This is chemistrytalk.org with talking about charges on the periodic table. Now, if I am a cation, I'm going to be a positive charge, which means I have lost electrons. So, yes, I'm positive I have lost electrons because now I'm going to have a positive net charge. If I'm an anion, I'm going to want to pick up that electron and I'm going to gain electrons. So that's where I'm going to get those anions associated with it. So looking at this particular page, you can see that I'm positive, I've lost an electron, and we're sure. So if we look at the periodic table, and this is really going to help you as we start to get into reactions and looking at our redox reactions, because we're going to look at how the ions either got electrons or added electrons to them or reduced by taking electrons away. So if we look at where things are in the periodic table, we know that everything in the alkali metals is a +1 charge. So that's really going to give you a nice handle on that +1 charge. If I go to the alkaline earth metals, those are +2. And in the middle here, those are all our good conductors. Those are going to have metallic bonding. It's what I refer to as electron soup, because we've got lots of electrons, they're in orbital shells, and we're going to learn a little bit more about orbital shells as we get there, but they're in orbital shells, and I can pick them up a lot better. And then we get to where those transitions are going to occur, and we have things like aluminum that are in this +3, where some things can act like a metal, and some things are going to act like a non-metal, or they call them the metalloids. They're kind of in between. So all of our metals are going to be our cations. Those are all going to be things that are going to want to give up electrons, and those are going to be positive. Now my anions are going to be over here on this side of the periodic table, where I'm going to want to pick them up. Now what's going to come out is we play, in general chemistry, we play a lot of who has the electron. Where is that electron and who has the electron? Well, everything in the halogens group is so close to being a noble gas, where they have all 8 of the valence electrons. And we're going to start talking about that here shortly, where we're looking at those valence electrons. So all 8 of those valence electrons are right there in our noble gases, and that's why we used to call them inert gases, because to try to get them to react was very difficult, because they don't want to give up their electrons. They're perfect. Okay, they're perfect. And as we start looking at that, that's what's really going to help us out. So my non-metals are going to be the ones that are going to typically be my anions, all right? There's my halogens, these particular ones, which are going to be -2. So you'll want to have a periodic table that kind of shows you those oxidation charges, or those charges. So here are my +1s, here are all my +2s. We got a lot of +3s. And then you can start to see where things get a little messy in that metalloids. But this gives you a nice periodic table of the common charges for our elements. And all my cations are going to be over here in our metals, and all my anions are going to be over here on our nonmetals. So hopefully that helps you out with that question, and thanks for the question.